So now we're going to number 5. Remember that it's the same pattern every time. You're going to start by writing the element symbol. And if there is a subscript, you're going to go ahead and write that symbol because that's going to help you remember that the subscript is there. To the left-hand side, go ahead and write the group number to make it easier to make your count. You're going to do a V for valence and a P for probable. Remember, the valence electrons come from the periodic table, and the probable electrons come from the chart on the front of the paper. So I'm going to look at carbon in 4A, and I know that a 4A element has 4 valence electrons. I'm going to look at sulfur in 6A, which means each one has 6, but since there's a subscript of 2, I multiply that by 2 to get a total of 12. Then I add 4 and 12 to get a total of 16 valence electrons. Remember, this is the actual number of valence electrons that has to be shown in your picture. I'm going to use the chart on the front of the page, just the number of electrons used, and figure out that a 4A element usually uses 8 electrons, as does a 6A. And just like before, I'm going to multiply that 8 by 2 with a subscript and add to get 24 probable electrons. To use math to figure out the number of bonds, I take probable minus actual, and that's going to give me 8. Divide that by 2 to figure out that I should be showing 4 bonds in my structure. Out of carbon and sulfur, carbon is obviously going to be in the middle. Now, if I look at this structure without putting any bonds in it, I really only have a place for 2 bonds. So if I look at 4 bonds with 2 elements, or 3 total elements, to attach to 1, the only way to do that is with 2 double bonds. Now, it doesn't make a lot of sense to do 1 triple and 1 single because that whole evenness is going to be gone. So the only way to combine 3 elements, 3 atoms, with 4 bonds is by double bonding. This is where the math, right here, indicates to you that you're going to have a double or triple bond. The other thing you remember is that the elements carbon, oxygen, nitrogen, and sulfur, cons, are very likely to form double and triple bonds. So in this case, I have 2 of those 4, so it's very likely that there's 2 double bonds there. And it also satisfies our math. So I'm showing 1 carbon, 2 sulfur. I'm showing 4 total bonds. I am not showing 16 electrons, however. I'm only showing 8. So I got to add an extra 8. Where they go, you figure out using the octet rule. If I look at carbon, since carbon has 4 bonds attached to it, it already has 8. It doesn't need 8. The 2 sulfurs on each end only have 4. So I need to add an additional 4 electrons. And keeping in mind that we want things to be even, the most logical place to put them is 2 on the top, 2 on the bottom. So now I'm showing 16 valence electrons.